Hello, I'm Steve Johnson. Welcome to DigitalWERX TV. Now, there are a lot of things we've been talking about over the past several weeks, and maybe we ought to kind of distill down to some definitions. And a couple of experts with me today. Chris Crumbly, the chairman of the board for DigitalWERX, and Ron Porter, the vice president of curriculum for DigitalWERX. That one, I don't know why it was kind of hard to say.
That's okay.
President of curriculum.
I usually don't even call myself that.
Sounds very important.
Maybe it's your writing.
That is entirely possible. Okay, first thing we want to talk about. We talk about DigitalWERX and we know what it means, but maybe everybody else doesn't know it quite like we do. So somebody out on the street says, Ron, what is DigitalWERX? What do you say?
I say you need to talk to Chris Crumbly, the director of DigitalWERX.
And Chris Crumbly would say DigitalWERX is a nonprofit really out there to help the industry and government organizations move towards digital transformation. That's the entire thing that we do, is just to try to enable digital transformation, focused on model-based system engineering.
Okay, and so but there are many components of that. Like you've got education on one end, but there are products also. There's products and services.
Yes, but where we started way back, Ron and I did when I got him off the Appalachian Trail, is we wanted to find a way to teach in the community college how to do model-based system engineering. How can I teach that in that genre? Then we moved forward to, well, we have to teach professionals. If we're going to bring these modelers in, the professionals need to know how to do that. And so we created classes there. We continued to work through the university. We started working with high schools. And so it got so large that we had something that we needed to focus on the government market. And that's where DigitalWERX came from.
Okay.
And you recognize that it's spelled W-E-R-X. That's not just
bad spelling. It's
yeah,
not
it's just bad spelling. I mean, it could be because
you mean it's not just for fun?
No. Well, it is for fun, but it copies the way many products in the surrounding the government market are branded, with works being spelled in that manner. So we were trying to identify with that market.
AFWorks, SpaceWorks, StrikeWorks, EnergyWorks, all of these WERX. And a lot of those are called PIAs, Partnership Intermediary Agreements. And it's a way for the government to work with a public entity and create a public-private partnership to move technology out quicker than maybe the government would do.
All right, so you cannot talk about DigitalWERX with anybody, especially you two guys, without model-based systems engineering coming up in a sentence or two. So what is model-based systems engineering?
Oh, I don't know.
Yeah, that's system. Okay, director of curriculum time. Okay, so system engineering is looking at the big picture whenever you develop a product or process and trying to make all the pieces of a very complex system work together well. So that occurs, and as that occurs, one of the things you try to do is you try to make sure all those pieces work together, and you end up creating mounds and mounds of documentation. That's so that this engineering discipline can read what this engineering discipline, and so the project manager can read what the business people are doing, so forth and so on. So model-based system engineering was brought in because a computer can help you link all of those things together much better. You can look at a bunch of PDF files. That's not digital engineering. Digital engineering happens when you start actually literally connecting the models together, when you start bringing everything together so that an engineer on this side of the project can look in and see what's happening with an engineer on the other side of the project. And that's model-based system engineering.
Have you ever used Word on, say, Microsoft Word on the collaboration platform, or Google Docs on the collaboration platform, where you could have it open, Ron could have it open, I could have it open, and we all type, and you see, oh, wait a minute, Chris is typing something, or Ron is typing something.
Well, I've used something similar to that, but I generally got irritated when I would see other people changing things.
See, our job is to take the irritation out of that. But
Okay.
really, model-based system engineering is a lot like that.
Okay.
But when you can put all of that information into one model, that is the source of truth. And all those documents that Ron talked about are really just in that model.
Okay.
So what happens in a complex project is everyone's in their little silo of activity. They don't necessarily see what's going on, and they depend on outside information sources as to where the project is. Well, everybody gets their outside information sources at a different time. So they're all in a different phase of the maturity of a project you're building. So no one is hardly in sync in the time and the maturity of the project.
Yeah.
When you get a model, everyone is in sync because they can look in at the same time other people are doing things.
Okay, so the model is always in sync.
That's the intent. That's
Okay, so that kind of answers the next question, which is why is model-based systems engineering the way to go? The future that we're already there. Why is it the thing you should be using right now?
Number one, speed. Speed of going from the mind of the designer to the machine that fabricates. That's the primary thing. But I think human error.
Yeah, it does that.
Mm-hmm.
It really prevents wasted effort. If people are working on one path, believing the project at a certain maturity level, when they're really off by some amount of time, then when they find out where the project is, they have to back up and fix what they've already done. And that is really wasted effort. And so the idea is keeping everybody in sync does exactly what Chris just said, which is speeds up the process.
And I've heard people talk about the fact that the old way with all that paper was a nightmare, and also getting people together for meetings. MBSE does away with that, doesn't it?
I wouldn't say it completely
No.
does
Okay.
away with it, because there's always going to be meetings. I don't think,
well,
I
yeah,
don't
that's
think the
for sure.
human being is capable of doing anything without having meetings. But it does reduce the size and the confusion associated with those meetings.
Yeah, it can mitigate it, but remember all those documents that Ron talked about?
Yeah.
The way that we have done it, and by the way, it may be a nightmare to have all those documents, but it was a horror movie to not have the documents at least to have that, right?
Yeah.
So all those documents need a human to read a document and translate that to another document that might go to a subsystem or a component or a part manufacturer. With the model, everyone can look at the same place,
Yeah.
and the human error is somewhat mitigated, but not eradicated.
Okay. And the changes, if you change one thing by doing this digitally, you can see how it affects all the other parts of whatever system you're dealing with.
Yeah, one of the things it does is there's always going to be a situation where you have to compromise.
Yeah.
And that compromise will require people sitting in the room looking at each other and making compromises in person. But the compromise need is identified much earlier.
Okay.
So you don't go downstream 2-3 months before you determine you have a problem in which you have to compromise. You get it up front.
Okay.
And still you have a meeting, you make the compromise, and you move on.
And the meetings can be digital, right? On Zoom meetings, you don't have to have everybody
Zoom,
flying across the
Teams,
country and
yeah.
sit in a room.
Yeah, sure.
Mm-hmm.
Okay. So we've talked about model-based systems engineering. What is a model? What is a model? What is a model, and who is a modeler? Put those together for me.
Okay, so I use this all the time. If you've got a pencil or a pen in your hand at the moment, if you were to make a picture of that, that would be a model of a pencil. Okay, so anything that represents something that is not that something itself is a model. So a model-based system engineering model is a representation of the system inside an electronic computer. And it turns out an MBSE model mostly are graphical. So you draw things inside the model.
So think about this. You've heard modeling and simulation. So a model is, like you said, it could be just a picture. A simulation is how would that model change over time? And that's called a simulation.
Okay. What is a modeler? Somebody who works on a model.
So think of a computer-aided design.
Don't just smile.
person.
Why didn't you just jump on that?
Yeah, a computer-aided designer, right? Someone
Okay.
who does computer-aided design. They're actually working in a model. It is a mechanical or electrical model of the product they're creating.
Okay.
Right. In this case, systems model, which is really what you're asking, a systems model is a representation at the big picture level on what the entire complex system is like. And it can be total and complete, in which case you get a digital twin, or it can look at just one section or one time frame of the project.
And the modeler is the human that enters that into the computer. And that modeler could be someone that has been trained in maybe a certificate level, could be a micro-credential, it could be a college associate's degree, bachelor's degree, a master's degree. So there's levels of modeling.
Yeah.
But what we have put together in the community college level over the last 5 years is a way to get a degree in modeling in a 2-year program. And then those system modelers can then help the system engineers actually expand their reach in how many systems and subsystems they can model by knowing what goes into the computer.
So back in the 80s when CAD came in, because I like to use this as an analogy, when CAD came in, most people thought we don't need draftspeople anymore. We can do it with the engineers. They can do it. But when you learn modeling, there's a lot of details with the model itself, the syntax, the way you put it into a model, the IT structure that surrounds the model that you have to be expert in. And the system engineer is busy system engineering, and they need a modeler.
Is that called going to meetings?
There's a lot of handshaking in system engineering, right? So they help, and Department of Defense would say they force leverage. Mm-hmm. They force leverage for a system engineer.
Okay, so you touched on this, but who can be a modeler? It sounds like community college graduates can be a modeler.
Yes.
But who can be a modeler in model-based systems engineering?
You could be a modeler. Would you like to be a modeler?
Yes.
The answer is
absolutely.
Yeah. Right.
But anyone that really has an affinity for the logic process of putting things into a computer, that understands, hey, I really like this STEM activity of working through the big picture, to be able to communicate that to my colleagues that might be in a different discipline.
And I'll go a little further than that. It's anybody who sees things at the big picture, thinks of things at the big picture. They see something and they go, oh, that's what that does. I'm interested in what that does. If you are interested in what a system does, you should be able to do modeling. In the case, the one exception I would make to what Chris says is that most of this is not syntax. You don't write lines of code, at least in the current revision of MBSE. It's graphical. You're drawing pictures and connecting things with lines. And there is not a lot of math involved for a entry-level system modeler. There is math in a model, but usually that's handled by the system engineer.
Now I used a word that could be misconstrued, logical. And when I say logical, what I really mean is a systems modeler is modeling what can be, not what is or what will be.
Okay.
Because as a systems modeler, you could be modeling the aspects and the functions of what you want a system to do, but you may not even know what it looks like in the end.
Okay. All right, so you mentioned not a lot of math. You said there was math in a model, but not a lot of math. Students or modelers don't have to know a lot of math. So, but they do have to be computer savvy, and that sort of wraps its arms around a whole huge group of high school students, doesn't it?
It does. I was on an airplane last year coming back from Orlando. And we know that coming back from Orlando, there's a lot of the passengers on the plane might have gone to certain amusement parks. And the ages go from in a car seat to older ones. And even the toddlers were asking for their iPads to be ready for the flight. So we have generations of students that have grown up not knowing life without some kind of computing device. And when you have that kind of generation, then you expect to work on the computer. You know how to work with a computer. You have an affinity for the computer. And so it's easy to adopt that into a STEM field.
Okay. All right, so we've gone from DigitalWERX down to who can be a modeler. Anything you guys would like to add to what we've said?
I do want to add a little bit on the math thing. So if you're a system engineer practicing in the field and you want to become a modeler, you certainly can do that. In that case, there's some math involved because that's the level of system modeling that will occur.
Yeah.
What I was trying to say is there are system modeling jobs that don't necessarily require a lot of math.
Okay.
And so folks who would really like to get into a STEM field, science, technology, engineering, and math, without the math,
Right.
STEM, okay, would like to get into that kind of area. They see the big picture. This is a way to do it without the fear of math. Now, I will say, over time, the system engineer who will be giving you the math to plug into the model, over time, you're probably going to learn it whether you want to or not. But it's not a scary thing.
No, and I want to be sure that any viewers out there don't think that we're throwing back on math. Math is the language of science, the language of engineers, and it's good. Now, it may be difficult, but speaking French is difficult for me because I don't study it. If I studied it, maybe it would be easier. If I studied more math, maybe it would be easier. So it's not a scary thing. It is a very useful thing, but we do not require advanced math courses to be a modeler.
Okay. Anything else?
Sounds good.
All right. Well, thank you guys. A lot of things we needed to kind of connect, I think, from DigitalWERX down to who could be a modeler, and you guys did a great job.
Well, thank you.
You asked the right question.
Well, I had the right answers. Thank you, guys.
All right.
And thank you for being with us on DigitalWERX. And remember, it works.